The next question is, how do Anna and Ben use trade in order to improve upon the initial endowment? So let's begin by deriving the equation for the contract curve. Remember that the contract curve represents the set of all points that are Pareto efficient. In order to be Pareto efficient, the points must be at a tangency between Anne and Ben's indifference curves. In other words, they must fulfill this criteria. The slope of the two indifference curves must be equal at the point of the tangency. So if we find Anne's marginal rate of substitution, that will be YA over XA. Ben's marginal rate of substitution will be 2xb yb over xb squared, which simplifies to 2yb xb. But you'll notice that when I set these equal, I don't have an equation that's very easy to plot, and that's because I have 4 different variables. Not good. What I need to do is get everything in terms of one person's problem. And the easiest person to look at is usually the one whose axes are not upside down. So in order to simplify this, we'll approach each problem from Anne's perspective. How do I get this contract curve in terms only of XA and YA? I can combine with the resource constraints. Remember that XA plus XB is equal to 8. So XB is equal to 8 minus XA. And likewise, YA plus YB has to be equal to 6. So YB must be 6 minus YA. Now, plugging into this equation, I have a function of just XA and YA. Unfortunately, it's not a very clean function to look at. And in order to solve for YA as a function of XA, I've got to do some rearranging. So I'm going to cross multiply. I've got YA times 8 minus XA equals XA times 2, 6 minus YA. And I can expand. Now I've got 8YA minus YAXA equals 12XA minus 2XAYA. I would like this to be a function of YA equals some function of XA, right? So I'm going to try to gather all my YAs to one side of the equation by adding this term on both sides. So I've got 8YA plus YAXA equals 12XA. Now again, I'm trying to gather my YAs together. So I have YA times 8 plus XA equals 12XA. And now I'm finally ready to divide. I've got YA equals 12XA over 8 plus XA. And that is the equation for my contract curve that I could plot within the Edgeworth box. I'm not going to take the time in this video to plug in values for XA and then plot YA, but you could do that quite simply here. I will show you what it looks like. Of course, like any contract curve, it will pass through the 2, 0, 0 points. And here we have a nice curve, something like this. So we can see that through trade, Anna and Ben could end up at any of these competitive equilibrium that would be Pareto improvements to our initial endowment point. The first fundamental theorem of welfare economics is that all competitive equilibrium are in the Pareto set. Why is that? Because a competitive equilibrium is a point at which all mutually beneficial trade is exhausted. If we can trade to benefit at least one of us without harming the other, we'll both agree to do so, reaching the competitive equilibrium and also fulfilling our efficiency criteria.